Thanks a lot, David. Thanks. Hope everyone is doing well. So in this session, I'm going to explore some of the common microservice communication patterns that you can build with gRPC. So, let me give you a brief introduction about myself. So I'm a director, senior director at WSO2 and also a product manager at WSO2. So I authored a couple of books, one on gRPC and one on microservices. And also I work closely with the microservices and cloud native communities in the Bay Area. So I think most of you have heard of gRPC and probably you are using gRPC in production even at the moment. But if you are new to gRPC, let me give you a quick overview of the protocol and then dive into the communication patterns. So as you know, when you are building cloud native applications, you usually design them as a collection of services. So these services are interacting with each other and usually use different inter-process communication technologies to bind or glue these services together. So gRPC is one such communication protocol that you can use as the inter-process communication between your microservices. So the key idea of gRPC is that you can invoke a remote application or a remote function as easy as making a local function call, right? So, for example, if you are new to, if you have heard of RPC protocols such as CORBA in the past, we are following the same set of principles here, but we sort of modernized gRPC to suit the modern communication protocols such as HTTP2 or protocol buffers. So the main concept of building a gRPC application starts with a service definition. So that's a place that you define your services business capability in the form of a contract. For that, you can use the protocol buffer specification for gRPC, where you specify all the services that you are exposing, as well as different remote methods. So once you have the service definition in place, then so this is a language and framework agnostic. So once you have this service definition in place, you can either generate the server-side code for your microservice or the client-side code for the consumer of that service. So you can generate code based on the language of your choice. gRPC supports a wide range of programming languages. So in this example, I have used Go as the server side and Java as the client side. And over the wire, we use protocol buffers used on top of HTTP2. Now, if I move to the service definition portion of a gRPC service, so as I said earlier, this is the place that you specify the business capabilities of your microservice. So in this example, you can see I have defined product info microservice, and I have a couple of remote methods along with the arguments and the return type. So all the required types are defined as part of the protocol buffer definition for your service. So one of the main reasons for using protocol buffers as the wire protocol is it's a language agnostic protocol, it's platform neutral, as well as it's high efficient data transfer or data serialization format. And so as part of the service definition, now you have all the services, service name, remote methods, and data types. And then the next step is to generate or build your gRPC service. So this can be done by using the service definition and then select the language that you're going to build the service with and simply generate the code for your server-side skeleton or the client-side stuff. So what it does is it generates all the boilerplate code by abstracting out all the required internal communication details protocol buffer serializations and so on. So as the microservice developer, what you have to do is you have to implement these business interfaces or these remote function interfaces and just fill them with your business logic. So you get different parameters based on the service definition. In this case, I get product ID as a parameter. And in this case, I get product as a parameter. In this case, I get product ID as a parameter to my function. So once you have the services business logic implemented, then you need to run your service. So that is done by creating a gRPC server instance. So here I have used the Go code sample. So it's just a matter of starting up the server on a given host and a port, and simply registering your service with the server that you have just created. So that's all you have to do at the gRPC service side. So when it comes to the client, it is quite similar. You just have to generate client-side stop for your client application, and from the using the stop, you can just connect. So now you here in my Java code, I have connect to my gRPC server, and then using the stop, you can invoke the remote method as easy as making a local function call. So those are the key concepts of gRPC protocol. Now let's dive into some of the key advantages that gRPC brings into the picture. So as I said earlier, owing to its data serialization format it uses, and also owing to protocol buffers, it's an efficient protocol compared to all the other most popular technologies such as RESTful services, which usually work on top of textual message formats. And because of having well-defined service contract and strongly typed messages, it is far more secure and far more robust than a conventional RESTful service, because you can easily handle errors because you are dealing with a very rich type system. It's polyglot, which means you can use multiple programming languages, because in the microservices architecture, you usually use a wide range of programming languages to build different services. So it has capabilities such as duplex streaming, where you can stream a set of messages from client or the server side. I'll go into the details later. And of course, since it's part of the CNCF, it has wide range of support from various other cloud native projects. So in most of the cloud native projects where you have to have high efficient inter-process communication, such as sidecar to main car communication, we usually use gRPC. All right, so let's dive into the communication patterns that you can build with gRPC. So the first one obviously is the simplest one, Unary or simple RPC. The same example I explained earlier. So in this case, you're sending a single request to your gRPC service and service response with a single response. Right? So always it's one request and one response. Service definition is very much the same as the one that we have seen earlier. So yes, this is the argument, one argument and one argument as a return type. So in the service side, it's a very straightforward implementation. I use a map and just returning the required order. Client side also, I'm just invoking the remote function. So this is very straightforward. Now let's go into a slightly complicated one. So this is server-side streaming protocol, where you can send a single request, but as part of the responses, you're getting multiple responses, which means you're getting a stream of responses from the service. Now, if I go to the service definition, it's again, you define an RPC service definition with your remote method, and as the return type, what you have is a stream of order objects. So that means the server can send multiple set of responses or multiple set of orders. So the server can determine when to mark the end of stream. Right? So you can keep on sending multiple messages and mark the end of the stream so that the consumer can detect the end of the stream. So in this example, in this Go code, you can see I have sent multiple order responses via the stream object that I have, and finally, by just returning nil, it marks the end of the stream. So client side also, you can continuously receive multiple orders using this stream that you get at the client side. All right, so this is client streaming, pretty much the opposite of server streaming. Here we are sending multiple requests to the server, and server is sending a single response back to the client. So in this example, so we are sending update orders, and it is a collection of orders that you're sending. And in the service definition, you can specify it as a stream of orders as the argument of the remote methods, and it returns a single value. So one important thing here is that the server can decide when to send the response. So server can either wait till it receives all the order request, or when it receives maybe one or two orders, it can start sending the responses back. So that is determined based on the business logic that you write. So in this case, we have waited till the end of the stream from the client side. And when we find the end of the stream, and then server responds back with a similar way that you have done in the server streaming scenario. And from the client side, again, you can keep on sending multiple requests. And finally, you can start receiving the response from the server. Okay, so next pattern, we have bi-directional streaming RPC. This is sort of a combination of server and client side streaming. This is slightly complicated if you look at the details of the business logic, but let's try to understand it using an example here. So in this example, I'm sending a collection of order requests to be processed by the order management service. And once it is processed, what you get is a collection of shipments. Right? So as you can see, inbound is also a stream of orders, and the outbound is also a stream of shipments. So in the service definition, what you can see is stream as the input parameter, as well as the return parameter also has stream identifier. So again, based on the business logic, this can be very different, but in this case, we have read entire stream and then start streaming back a set of shipments to the client side. So same applies to the client application. And here, as you can see here, the client can receive shipment orders, shipments in a separate thread even. So if you prefer, you can completely decouple sending and receiving in a separate thread. So those are the 4 main communication patterns that you can build your microservices with using gRPC. And let's look at some of the other supporting communication patterns. So usually when you're building gRPC applications, it is very common to have a common business logic either before or after the execution of a remote function call. It can be done at the server side or the client side. So gRPC introduces a concept of an interceptor where you can plug your own interceptors at the server and the client side. So these interceptors can be applied for Unary or simple RPC or for streaming scenarios. So in the Unary's case, you can attach an interceptor so that you can do a pre-processing of the incoming RPC. Then you can do the invocation from the interceptor itself. And also you can do post-processing of the RPC. So that is very useful when you're building things such as login authentication, or making your microservices observable, and so on. And in the streaming case, you can intercept any message. So if you are using client-side streaming, you can intercept to each and every message that are coming through that stream. All right, so then let's talk about deadlines. I think you have heard of concept of timeouts and deadlines in most of the microservices use cases and patterns. The key idea here is that you can define, so for example, when you have a series of microservices communicating with each other, you can define an absolute time from the beginning of a request, and you can apply it across the entire life cycle of the request. So usually deadlines are applied at the client side. So when prior to invoke a RPC from the client side, you can set a deadline. So when that particular deadline expires, you can invoke a specific business logic in your application, in your client application, so that you can gracefully handle the deadline. So it is very similar to this timeouts or any circuit breaker related resiliency patterns that you develop with your generic microservices. So it's the same concept here as well. So then you can use metadata when you are building inter-service communication. That means there are certain set of data that are not directly related to the business logic of your microservice. So, so usually if that is part of the business logic, it is always recommended to use RPC methods, because at the end of the day, the business contract is defined in your service definition, right? So it's always good to send business data as part of the regular RPC course. But if you want to send some generic or some commodity data, which are not part of your business logic, so that's where you can use metadata. And so the way that you send GRPC metadata is you can initiate metadata from both client and the service side. And usually we create metadata in the form of GRPC headers, and it has the structure of simple key value pair structure. So you send all these GRPC headers as a key value pair. So usually most of the security headers in GRPC context are implemented using metadata. Then the next pattern is multiplexing. So this may not be a very common thing, especially in the context of microservices. So this is all about running two service instances in the same GRPC server. So in the very first example, I showed you that you can register a service with this GRPC server that you create, right? So once you have a service, once you have the server, you can actually register multiple services, right? So this is a pattern that uses two different services on the same GRPC server. So in the context of microservices, maybe you can host more of a like a co-located or similar services in the form of a single GRPC server. Then the next one is cancellation. So so when you do when you initiate an gRPC channel, then what you can do is from either the client or the server side, you can determine when to terminate the connection. For example, if you're doing streaming, if a particular message that are streamed over the network is maybe you want to terminate the connection by looking at the message, then what you can do is you can just cancel the connection from either of these sides. So cancellation is a method to propagate that signal to the other party. So it can be server or the client. So once a particular RPC is cancelled, then no further RPC can be done over that connection. And the other party can determine it by just checking the status of the connection. If that is cancelled, so that means it has to, that party has to gracefully handle the scenario. So usually when you are doing a critical RPC related business logic, it's always better to check the status of the cancellation. So usually this is quite useful when you're doing complex duplex streaming, as we have seen earlier. The final pattern, it's GRPC gateway. So as you know, most of the GRPC services, you may have to expose them as RESTful services, right? So in this case, rather building a reverse proxy from scratch, what you can do is you can simply use the same protocol definition file, service definition file that you use to create the service. And you can use the same thing to generate this reverse proxy. So GRPC Gateway is a ecosystem project of GRPC, where you can use that binary as the sort of the gateway to your all incoming requests. So in this case, it is doing protocol transformation. The inbound is JSON over HTTP1, and the outbound is GRPC over protobuf. All right, so with that, we can summarize all these different communication protocols, all these patterns. And what we are seeing in most of the pragmatic microservice deployments is that GRPC usually used with other technologies such as REST, such as GraphQL. So in most deployments, what we are seeing is internal communication is usually implemented using GRPC for all the internal microservice communications. And then we have external facing services usually implemented with REST or GraphQL, and they are usually fronted by an API gateway. That's where you apply all the security and build the entire API ecosystem around your services. And also in certain use cases, such as streaming, can also work in tandem with other event-driven protocols, such as Kafka, Nets, alongside a message broker. So in summary, GRPC can be used with usually most commonly used with all the other communication technologies than just a single one single technology to build your entire microservices ecosystem. So with that, I would like to wrap up the session, and let me share some of the resources. So most of the examples that I showed you are available in this source code repository. Actually, this is the source repository of the GRPC book that I explained earlier. And you can find Java and Go code examples there. And also there are multiple other patterns that I haven't discussed today, also included in the same source repository. So if you have any questions, feel free to raise them through the Slack channel.